open up. And when the aortic valve opens up, then the pressure, not within the ventricle, but within the aorta, because the aortic pressure, which is shown here in red, is really a function of the contractility of the heart. So it goes up to 120 millimeters of mercury. So the cool thing about that is that by recording blood pressure here and looking at the systolic blood pressure, we actually know what is the systolic pressure within the ventricle itself. If we were looking from over here, which I told you is not good practice, the value is going to be about 5 millimeters less. Yeah, it's only 5 millimeters, but it's not as accurate of a measurement that we like to have. And certainly in a clinic, you don't want the physician's assistants recording blood pressure one time with the left arm and the next time with the right arm. There's got to be some consistency, and the convention is to always do that on the left arm, simply because it places you closer to the left ventricle. If you trace down at the bottom, ventricular volume. Well, our standard textbook value for ESV is 50 milliliters of blood. Here we are right there at the end of systole. Now we have ventricular filling. This is diastole here. Then we have ventricular ejection. This phase here is ventricular ejection. So sometimes it takes a while to understand what these graphs are trying to show you. But again, there's a logic here, and the logic is during diastole, the intraventricular volume is going up, and during systole, the ventricular volume is going down. Our standard textbook value for end systolic volume is 50 milliliters, and sure enough, here we are, right about there. Our standard textbook value for EDV is 120 milliliters, and sure enough, we're right about there here. Now, here's kind of where you've got to go with this. So you've got to memorize all this, you've got to understand the logic behind all of it, but then you have to be prepared for what if we come along and we have an individual, Mrs. Jones, who's in heart failure. And the question I have for you is what will happen to the shape of the pressure volume diagram when heart failure is present? Mr. Cobb, what would you say is going to happen to the end systolic volume? We've got an individual who's in heart failure. The heart's not able to contract with a normal amount of force. So what's going to happen to end systolic volume?
It would be higher.
It's going to go up. Let's test it and let's see. And this is the beautiful thing of the simulator here. We'll see if this works. So here's our pressure volume diagram, and what we're predicting is that the end systolic volume, here's our ESV right here, we're predicting that the curve is going to shift over to the right. Let's see if that happens. How do I do that? I simply go to the slider for contractility. That's this slider here, and I'm just going to drop that indicator down below normal, which is highlighted by that red dot. So here we go. So it's reduced. And not only that, but what's happened to the peak pressure? If you have a heart that is failing as a pump, hopefully you would predict that the systolic blood pressure is going to drop. And we see that here. So we see a slight shift to the right due to a decrease in contractility. That means our ESV is going up. And because the heart's not able to produce as much pressure, we expect that the peak pressure, the systolic pressure, is going to be lower than normal. Yes?
Adjust the contractibility heart rate.
Oh, come on, I'll have to do that in just a moment. Let's think about exercise. During exercise, the heart has to contract with a lot more force. During exercise, the sympathetic branch of the autonomic nervous system is dumping a lot of norepinephrine onto the heart. It's going to cause the heart to contract with more force. So let's see what's going to happen with contractility. And what I would predict is that if we increase contractility, the ESV is going to come over this way a bit. Let's see if that happens. There we go. Because the ventricles contract with more force, we're pumping more blood out. That means that our end systolic volume is going down. The difference between EDV and end systolic volume gets larger, which means stroke volume has gone up. And that's what we see. This is our stroke volume, right? That's simply the difference between EDV and ESV. And because the heart is contracting with more force, the peak pressure goes up. So these are the types of things that you should be able to predict tonight, and especially come test time. All right, let me come over here and help you with that.
This is the picture from the document.
Yeah, let's do this. Now, what's funny? Yeah, what's funny is when you're doing this, you're like, oh, okay, it should be very simple, but it's not. And so eventually you play around with it. So, as you saw me do, I'll just come up here. And then we just erase it. Change it right there. So let's come back here. We'll just come back. How about we get preload? So preload is our intention. So if we increase the preload,